Hello, good morning everyone. Myself Sharik Mohammed. My project is on AI-enabled cybersecurity reliance at Lloyds Banking Group, where this study evaluates how Lloyds Banking Group can strengthen cybersecurity reliance while continuing to expand its use of artificial intelligence, cloud services, and digital customer channels. The key management question is not simple whether AI can improve cyber threat detections. It is whether Lloyds can introduce an AI-enabled cybersecurity risk management platform in a way that is strategically valuable, operationally controlled, and accountable to customers, regulators, and senior leaderships. My analysis considers the organizational challenge, adoption readiness, evidence from comparable organization, alternative strategic options, and the governance required from the implementation. The conclusion is that Lloyd should not improve immediately to enterprise-wide development. It should begin with a vendor support but internally governed pilot support by clear decision gates and measurable performance criteria. Coming to the second slide, strategic background and objectives. Lloyds is already generating material value from artificial intelligence. The organization reported approximately 50 million pounds of value from generative AI in 2025, with more than 100 million pounds expected in 2026. This creates a strategic tension as Lloyds becomes more dependent on AI, digital services, and cloud infrastructure. The possible impact of a cyber incident also increases. The external environment reinforces this concern. In Bank of England's 2025 second half systemic risk survey, 86% of respondents identified cyber attack as a major risk to the UK financial systems. The National Cybersecurity Centre also expects AI to increase the speed and effectiveness of cyber instructions activity through 2027. The Financial Conduct Authority requires firms to demonstrate that important business services can remain within approved impact tolerance during serious disruptions. These pressure may cyber security a board level issue linked to customer access, payment continuity, regulatory confidence, and organizational reputation. The project aim is to evaluate the feasibility of an AI-enabled cybersecurity risk management platform and develop to 12-month implementation roadmap. The four objectives are to assess organizational readiness, compare strength alternatives, define governance and risk controls, and produce a phase plan with clear milestone and measurable benefits. In third slide, we'll see about the organizational challenge. The problem map shows how external threats interact with internal organizational weakness. Lloyds faces faster AI-enabled attacks, a larger cloud and API footprint, and increased dependence on technology suppliers. This pressure becomes harder to manage when security data is fragmented, systems are poorly integrated, monitoring remains highly rule-based, and accountability is unclear. The result may be delayed detections, slow containment, and alert fatigues, and inconsistent escalations. This operational weakness can then lead to a financial loss, service disruptions, regulatory exposure, and reputational damage. The main insight is that proposed platform can be treated as another isolated security product. It must connect data, threat intelligence, human judgment, governance, and incident response around Lloyd's important business services. This is therefore an organizational transformation and technology management challenge rather than simply a software purchasing decisions. Coming to the fourth slide, research methodology and project approach. The project uses a structured secondary research design because it proposes is to evaluate strategic feasibility and implementation governance rather than build a technical prototype. The evidence-based combines pre-reviewed research, regulatory publications, Lloyd's disclosures, industry reports, and named organizational case studies. Sources we assessed according to relevance, credibility, methodology, transparency, currency, and acceptability to large regulatory financial institutions. Four main framework we used. A technology organization environment framework assess technical capability, organizational readiness, and external pressure. McKinsey 7 is examine alignment across strategy, structure, systems, skills, staffs, leadership styles, and shared values. NIST Cybersecurity Framework 2.0 define the required outcomes across governance, identify, protect, detect, response, and recover. PMBOK and StageGate principles translate the analysis into delivery milestones, risk reviews, and executive decision points. Cross-case comparisons was then used to identify recurring benefits and implementation lessons before 5 strategic options were evaluated. The methodology also recognizes the vendor case studies may favor positive outcomes and that results from other organizations may not transfer directly to Lloyd's. The evidence is therefore used to establish testable expectations rather than guarantee benefits. Coming to the next slide, key findings and cross-case evidences. The case evidences shows a consistent pattern. Value is created when automation is selective, security data is integrated, and human accountability is retained. D-commerce Bank reported a 50% reduction in security alerts and an increase in encrypted traffic inspections from 8 to 100%. The lesson is that the result dependent not only on AI but also integration, reliance, architecture, and workforce preparations. Bank Central Asia used approximately 85 security architectures playbooks to process around 740,000 tickets, including 30,000 full automated cases. This shows that automation can operate at scale when activates and repeatably and support by clear escalation rules. Ascari Bank reported reducing incidents requiring analyst attentions from approximately 700 per day to fewer than 20, while reported response time reduces from around 30 minutes to approximately 5 minutes. This suggests that reducing false positive can release scarce analyst capacity. However, alerted users must not result in genuine threats being missed. Mitsui used Microsoft Security Copilot to support alert interpretation while retaining human involvement in sensitive fraud and compliance detections. 4 findings are therefore relevant to Lloyd's. First, automated high volume and low risk activities before conceptual actions. Second, integrate and platforms with existing security system and workflows. Third, retain named human approvals for high impact decisions. Fourth, establish performance baseline before the pilot. Key measures should include detect time, response time, false positive rate, service ability, analyst workload, and compliance expectations. Coming to sixth slide, strategic options evaluations. 5 strategic alternatives were assessed. Enhancing existing rule-based control would be relatively feasible and less costly, but would not sufficiently address adaptive threats or fragmented visibility. A fully managed external service could increase capacity but could create a greater supplier dependence and reduce internal learnings. A commercial platform deployed largely as supplied would provide strong functionality but could create integration, customization, and vendor lock-in risks. A bespoke internal platform would provide greater control but would require scarce expertise, high investment, and a long time to value. The highest ranked option is a hybrid vendor supported AI-enabled cybersecurity risk management platform under internal Lloyd's governance. It combines mature external capability with internal ownership of data, architecture, risk acceptance, human oversights, and benefits realizations. The weight score is not intended to imply certainly, it makes the trade-off transparent. The recommendations is therefore to approve a controlled pilot, not unrestricted enterprise or procurement. Coming to the seventh slide, a 12 months implementation roadmap. The recommended program runs for 12 months and avoids a big bang deployment. In phase 1 establishes governance, scope, success measures and readiness. Phase 2 covers vendor selections, due diligence and investment approvals. Phase 3 defines a target architecture, prepares governed data pipelines and integrates the platforms with existing security systems. Phase 4 is bounded pilot in a high risk but operational controlled business service. The pilot should test detections quality, response time, false positives, privacy, reliance, explainability, and user adoptions. Phase 5 combines role-based training, change preparations, and controlled rollouts. Phase 6 reviews benefits, reducial risk, and transfer ownership into business as usual operations. 6 decision gates support executive controls, scope approval, investment approval, pilot readiness approval, and go or not go decisions, service acceptance, and project closure. Gate 4 is especially important because it separates pilot learning from vendor deployment. Governance should assign strategic sponsorship to an executive steering group, security accountability to the chief information security officer, and delivery responsibility to the program manager. Privacy, model risk architecture, procurement, and operational reliance specialists should provide independent challenge. This approach allows senior leaders to pause, redesign, and terminate the program if the expected value and controls are not demonstrated. The last slide of the project, recommendations and conclusions. This is based on the analysis. 5 actions are recommended. First, established executive governance before procurement, including clear decision rights, risk appropriate, and pilot acceptance criteria. Second, procurement against measurable outcomes rather than supplier claims, with requirement covering integration, explainability, data protection, service levels, and exit arrangements. Third, conduct a bounded pilot and compare the results with agreed baseline before wider deployment. Fourth, apply risk threaded automation. Low risk repeatability actions may be automated. Medium risk actions should require analyst confirmation, and high impact decisions should remain subject to named human approval. Fifth, scale the platforms only when both benefits and control have been demonstrated. In conclusion, the hybrid AI-enabled cybersecurity risk management platform provides the strongest balance of security improvements, organizational control, and delivery feasibility. Its strategic value does not come from adopting AI for its own sake. It comes from protecting customer trust, regulatory confidence, improvement, business service, and the value of Lloyd's wider digital transformations. My final recommendation is that Lloyd's approve a governed pilot with enterprise rollout depending on verified improvements in detection, response, reliance, and responsible human oversights. Thank you for this chance for listening.